Hi class, here's the homework video for May 1st, Thursday, May 1st, 12.2, surface areas of prisms and cylinders. Okay, so the directions say find the volume and the surface area of each rectangular prism, and we want the exact answer. Notice I'm not asking for the lateral surface area. We're just going to do the volume of the rectangular prisms and the surface area, the total surface area. Okay, so the volume is equal to the area of the base times the height. Or as we talked about in class, it could also be length times width times height, where length times width is going to be the area of the base. Okay, so the volume equals 4 times 3 times 5. Oops, and that equals 60. So that's our answer for the volume. Now our surface area is going to be equal to 2 times the length times the width plus 2 times the width times the height plus 2 times, let's see, we've got the length times the width times the height, 2 times the length times the height. So 2 times the length times the width is going to be this base and this base. There's 2 of them. Then 2 times the width times the height is going to be the 3 times the 5. So that's going to be these faces right here, this one and this one. And then the length times the height is going to be the front of this. 4 times 5 is going to be this face here in the front and the one behind. And that will be the sum of, if we add up all those areas, we will get this total surface area. Okay, so let's do the numbers. So surface area equals, okay, 2 times 4 times 3 plus 2 times 3 times 5 plus 2 times the length times the height, and that's 5 times 4. Okay. And then we just do the math. So this is 12 inside of here, so 2 times 12 is 24. This is 15 inside of here. Excuse me. So that's 2 times 15, that's 30. This is 20 inside of here, so 2 times 20 is 40. And we just add those up, that's 70, 94. And that's going to be the surface area. All the sides, the area of all the sides added up. Okay, let's do the next box. First we're going to do the volume. Volume equals base times area of the base times the height, or like I said, you could use length times width times height. So 8 times 12 will give us the area of the base. That's 8 times 12. And then we multiply that times 6. And 8 times 12 is 96 times 6. It's 36, 576, and this is meters cubed because that's the volume of that box. Now our surface area is going to be equal to 2 times the length times the width. So if you wanted to call this length, width, and height, you can do that. So 2 times length times width, that's 8 times 12, plus 2 times, now we also need the width times the height, so 12 times 6, plus 2 times, now we need the front face. So the front face is 8 times 6, that's length times height. Okay. And then we just do the math to add up all these areas. So this is 2 times, that's 96, so it's 2 times 96 plus 2 times 72 plus 2 times 48. Okay, I'm going to go ahead and do this in my calculator. 96 plus 72 plus 48 equals times 2 equals 432 meters squared. We're talking about all the total surface area, the area of all the sides added up. Number 3, first we find the volume. That's going to be area of the base times the height, or length times width times height. So that's equal to the length times the width is rad 3 times rad 2, and then the height is rad 6. If we multiply these all together, we get 3 times 2. These are all on the inside, so 3 times 2 is 6, times 6 is 36. That all stays on the inside. And we take the square root of 36. It's a perfect square, and there's our volume. Now our surface area is going to be equal to, so let's just maybe shade it in instead of using the exact formula. We need this base and this base, so that's 2 times rad 3 times rad 2 plus 2 times, well, we want this side here. Okay. We want this side and this side. So that's going to be rad 2 times rad 6 plus 2 times, now we want the front and the back. Now we're going to want the front and the back. And that's going to be rad 3 times rad 6. Alright, and that gives us the area of all the faces. Then we do the math. So this is 2 times rad 6 plus 2 times rad 12, right? 2 times 6, that stays inside, plus 2 times rad 18. We'll need to simplify in here, so we have 2 rad 6 plus, well, we have a rad 12, so we can take out, that's the same thing as 2 rad 3, right? 4 times 3, so we take out the square root of 4. So that's 4 rad 3 plus, here we can take out a 3, so this is 3 rad 2. So 2 times 3 on the outside is 6 rad 2 on the inside. And we cannot add these up anymore because they are not like radicals. So just leave it like that. Okay, number 4. The cube, the area of a cube could be written as 6 times s squared. Right? We're going to find all the sides of this, all the sides have the same area. So the front, the back, the sides, the top, the bottom, they all have the same area because it's a cube. And the area of each face is side squared, which is 4 times 4, which is 16. So we have 6 of these faces, and they're each 16, so that's where we get this formula. 6 times 16, so that is 96 inches squared, and that's the total surface area. And I forgot to do the volume, so let's do the volume. Volume equals length times width times height, or area of the base, 16 times the height, which is 4, and that's 64 inches cubed. Okay. Now we'll do the volume, lateral area, and surface area of each prism. I'll be right back. Okay, now we're going to find the volume, lateral area, and surface area of these prisms that are not boxes. So volume equals area of the base times the height. Same formula, really. Okay, I'm trying to zoom in. So the area of the base, well, the bases here are the front side here and the back side. These are the two that are parallel to each other and congruent. So these are triangles, so the formula for the area of a triangle is 1/2 base times height. And we'll multiply that times h, which is the distance between the two bases. So 1/2, the base of this triangle is 4, and the height is 3. And the distance between these two is 6. That's the height. Okay, so this is 1/2 of 12 is 6 times 6 is 36. Now, we're going to find that's the volume. Oh, and there's no units. Okay, lateral area is going to be equal to the perimeter of the base times the height. So what is the perimeter of this base? It's equal to 3 plus 5 plus 4. So this perimeter all the way around is 12. And then this height is 6. So we get 72 is our lateral area. Now to find the surface area, we're going to take that lateral area and add it to 2 times the area of the base. Right? The lateral sides are 72. Now we need to find the area of the bases, and there's 2 of them. Okay, so 72 is our lateral area, and just a second. And the area of our base is 1/2 base times height. We already found it in the volume. It's 6, but we can plug it in again. So 72 plus 2 times 1/2. The base is 4. The height is 3. So this is 72 plus 2 times 6. See, we found our area earlier, right here. And that's 72 plus 12, which is 84. And that is our total surface area. Our lateral area, we should expect to see that be less than our surface area, because the lateral area is just the sum of the area of all the sides. Now we're adding also the area of the bases to it. And that's our total surface area. Okay, number 6. And find the volume first, and that's the area of the base times the height, or the distance between the bases. Okay, now looking at this shape, I see that this top side right here, I can use a pencil, this top side right here and this bottom side right here are the bases. So we'll find the area of this trapezoid. Now the formula for the area of a trapezoid is 1/2 times B1 plus B2 all times the height. I should have put that in the square bracket. So that is the area of the base, and then the height is the distance between them, so that's 16. Okay, so the volume, again, the area of the base is 1/2 times, well, this is 10 and this is 14, so this is 14. And the height, or the distance between them is, the height of the trapezoid. So 1/2 times 10 is one base, 14 is the other base, and the height of the trapezoid is 3. That's going to give us the area for the trapezoid, and then we multiply it times this height, which is 16. Okay, so this is 1/2 times 14 times 3. That's still our area, all times the distance between them. That's 7 times 3, that's 21 times 16. And I'm keeping this in parentheses for a reason. I'll show you why in a minute. All right, so 21 times 16, and I'm going to go ahead and use a calculator for that. 21 times 16, and that's 336. That doesn't seem right. What did I do wrong? 1/2. Oh, this is 24. 10 plus 14 is 24. So 1/2 of 24 is 12 times 3. So this is 36. Sorry about that. This is 36 times 16. Sorry. 10 plus 14 is 24. All right, so 36 times 16 is equal to 576. That's our volume, 576 feet cubed. Okay, our lateral area is going to be equal to the perimeter of the base times the height. So the perimeter of our base is adding up all these sides, 14 plus 7 plus 10 plus 4. We'll go ahead and do that. 14 plus 7 plus 10 plus 4. And then we're going to multiply it by this height again between them, 16. So that's 21, 31, 35 times 16. And 35 times 16 is equal to 560. So our lateral area, the area of all the sides that are not the bases, is 560. Now our surface area is going to be equal to that plus the area of the bases. Well, we found the area of the base. It's 36. So I'm just going to say it's 560 plus 2 times 36. The area of this base is 36. That's 560 plus 72. That's 632 feet squared. Now I forgot to put the feet squared over here on the lateral area. There we go. Okay, back side, we're still finding the volume, the lateral area, and surface area of the prisms, and we want the exact answer. So if there's a radical or a pi, we're going to leave it that way. Okay, we won't be any pi's here, but there'll be maybe some radicals. Okay, so volume is equal to the area of the base times the height. The area of this base, notice that these bases are triangles, so this is a base and this is a base. So the formula is going to be 1/2 base times height, all times height. So this is 1/2. Now the base of this triangle is 6. But each piece of this is 3 and 3. And the reason I'm splitting that up, because this is an isosceles triangle, so this height is going to split this into 2 equal parts. But I need to find h. Now notice this is a Pythagorean triple. Do you remember? 3, 4, 5 is a Pythagorean triple. If you don't remember the Pythagorean triple, you can just use the Pythagorean theorem. Okay? 3 squared plus h squared equals 5 squared. H is going to equal 4. So this is height is going to be 4. So 1/2 times the base of 6 times the height of 4. That's going to be our area, and then we're going to multiply that times the height, or the distance between the two bases. That's going to give us our full volume. Okay, 1/2 of 6 is 3, times 4 is 12. That's our area, times 7, and that's going to be equal to 84. Okay, that's our volume. Now our lateral area is going to be the area of all the sides added up. Remember, that's the perimeter times the height. So the perimeter of this base is 6 plus 5 plus 5. So 10 plus 6 is 16. Right? The perimeter is 5 plus 5 plus 6. That's 16. Then we multiply that times 7. The height, 16 times 7 is 2. Carry the 4. That's 112. So our lateral area is 112. Our surface area is going to be equal to that 112 plus the area of the two bases. Well, 112 plus, we know the area of the base is 12. So put that right there. We found it up here. So that's 112 plus 24. That's equal to 136. And that's our total surface area. Lateral sides and the two bases. Okay, number 8. We're going to find the volume, and we're going to find, and then we're going to find the lateral and surface area. Okay. So the volume is equal to the area of the base times the height. And these triangles, in this prism, these triangles are the bases right here. Right? They're parallel to each other and congruent. Well, what is the area of a triangle? It's equal to 1/2 base times the height times the height. So you can find the height by dropping down your height right here, which makes this 5 and this 5. And because this is an equilateral triangle, we end up with a 30, 60, 90. So we can use this method here. So the the area of the base is 1/2. The base is 10, and the height is going to be, well, if this is the hypotenuse, then this is the short leg, it's half of that. The long leg is 5 rad 3. So our height is 5 rad 3. And we multiply that times the distance between the two bases, or the height, which is 8. Okay, so inside of here we get half of 10 is 5. 5 times 5 is 25. So we get 25 rad 3 times 8. And then when we multiply this 8 times this 25, we get 200. rad 3. And that's our volume. I mentioned that you could use this formula instead to find the area. So I could have done this instead. To take the side and square it. So that's 10 squared. Rad 3 over 4. And then multiply that times the distance between them. And if you simplify this, you get 100 over 4, which is 25 thirds, 25 rad 3 times 8. And you get the same, see how you get the same thing here? So this formula right here can be a little quicker. It got me there a little bit faster. But you can certainly just use the 30, 60, 90s that you get with this equilateral triangle. Alright, so that's the volume. Lateral area is equal to the perimeter of the base times the height. So the perimeter is 10 plus 10 plus 10, so that's 30. And the height is this distance between, so that's 8, that's 240. And our surface area is going to be equal to that 240 plus 2 times the area of the bases, right, because there's 2 bases. So if we find the area of the one base, we just multiply it by 2 and add it to the other side's area. This is 240 plus, well, we know the area is equal to 25 rad 3 because we did it here. So 25 rad 3, and I also did it here. 25 rad 3. And then we multiplied it by the height. Okay, so 240 plus 2 times 25 is 50, rad 3. And we cannot combine these because they are not like radicans. And so that's the surface area. Okay, number 9. We're going to find the volume first, which means we need to find the area of the base. So the volume is equal to the area of the base times this 11. Okay, well, what is the area of the base? This is a regular hexagon. So the formula for the regular polygon is 1/2 times the apothem times the perimeter. That will give us the area of big B, and we'll multiply that times 11. Okay, so this is going to be 1/2. Well, what is our apothem? We have to find it. We have to find our apothem. Remember, in a hexagon, all of these angles are 60 degrees going to the, oops, that's not right. I drew that wrong. All of these angles to the vertices are 60 degrees. Scratch that, scratch that. All these angles here. So these angles are 60 degrees. I don't have my white out handy, but anyway, those don't count. So that means that this splits, this apothem splits this triangle into a 30, 60, 90. 30, 60, 90. So if the side is 2, then if we split it in half, this is 1 and this is 1. So if this short side is 1 of this 30, 60, 90, then A is equal to 1 rad 3, which is just rad 3. Okay, I'm going to redraw that out here. Here's our triangle. This is 1 because, right, the other one is also 1. But we want to look at this triangle. This angle right here is 30. And this angle right here is 60. Okay, so if this short side is 1, then this long side of this triangle right here is 1 times rad 3. Well, 1 times rad 3 is just rad 3. So we have 1/2 times the apothem of rad 3 times the perimeter of it, which is 12, right? 2 times 6. That's going to be the area of that base. I'm sorry for that messiness there. And then this is times the height, which is 11. Okay, so inside of here we get 1/2 of 12 is 6. So that's 6 rad 3. So that's the area of the hexagon, and we'll multiply that times 11. So our total volume is 11 times 6 is 66 rad 3 meters cubed. And that's our volume. Now we're going to find our lateral area, and that's equal to the perimeter of that base times height. Okay, so the perimeter of the base is 2 plus 2 plus 2 plus 2 plus 2, 6 times, so that's 12. and the height is 11. So 12 times 11 is 120 plus 11 is 131 meters squared. And that's our lateral area. Now our surface area is going to be equal to that 131 plus 2 times the area of the base. So what is the area of our base? 6 rad 3. This is 131 plus 2 times 6 is 12 rad 3, and that's our total surface area, and that is also meters squared. Okay. Okay, number 10. Find the volume, lateral area, and surface area of each cylinder. This time also we want the exact, so that means leave pi as pi, right? Okay. So the volume is equal to the area of the base times the height, but we know the area of the base is pi r squared, so it's pi r squared times the height. Okay, so the radius here, so it's pi times 5 squared, that's going to be our area, times the height of 7. So that's 25 pi is our area. We're going to multiply that times 7. And 7 times that is 175. 7 times 25 is going to leave pi as pi. And that's feet cubed. Now we're going to find the lateral area and the surface area. This maybe I'll do it. I'm going to do it here. Lateral area. The lateral area is equal to the perimeter times the height, but in this case we know that the perimeter is going to be the circumference, 2 pi r times the height. So that's 2 pi times 5, and the height is 7. So that's 10 pi times, or excuse me, 10 times 7 is 70, so that's 70 pi feet squared. Now the surface area is going to be equal to that curved part plus the two bases. The area of the bases is 25 pi, right? Pi r squared. But we already know it's times 2. So we already know that the area is 25 pi. So that's times 2. So that's 70 pi plus 50 pi. That's 120 pi. And that's going to be feet squared. Circle your answers, please. Okay, number 11. Volume equals area of the base, which is pi r squared, times height. Okay, so our area is pi. Well, if the whole diameter is 6, then half of it is 3. So that's 9. Okay, 3 squared. Radius is 3. Times the height. Oh, we don't know what it is here because it's not listed, but we do have a right triangle, and this is not a 3, 4, 5 Pythagorean triple. It's a 6, 8, 10, right? You double each measurement. So this is 8, but you can use the Pythagorean theorem to find that. Okay, so 11 times r squared times 8. That's 72 pi yards cubed, and that's our volume. Now our lateral area is going to be equal to 2 pi r times h. So that's 2 times pi times 3, and the height is 8. 2 times 3 is 6, times 8 is 48 pi yards squared. So that's our lateral area. Now our surface area is going to be equal to that lateral area, 48 pi, plus 2 times the area of the base, and the area of the base was 9 pi, right? Pi r squared. So that's 9 pi. So that's 48 pi plus 18 pi. If we add those together, we get 66 pi, and that's going to be yards squared. Number 12, a cylinder with radius 10 and height is 10. That distance there, that height. Okay, so volume equals pi r squared times h. Well, our radius is 10, so pi times 10 squared times the height. So that's equal to pi times 100 times 10, that's 1,000. So our volume is equal to 1,000 pi. Now our lateral area is equal to perimeter times height, which is 2 pi r times height. So 2 times pi times 10 times 10. That's 100, that's 200 pi. And their surface area is equal to 200 pi plus the two areas of the bases, so that's pi r squared. So 200 pi plus pi times 10 squared. It's up here, but I'm going to go ahead and do it because I kind of did it in two steps, or one step. So that's equal to 200 pi plus 100 pi, right? 10 squared is 100. So we get, oops, forgot to multiply by 2. Right, there's two bases, top and bottom. So 2 times that, so that's 200. So 200 pi plus 200 pi is 400 pi, and that's our total surface area. 200 pi plus 2 times the areas of the bases. Okay. Challenge. Well, I'll get you started. The surface area of a cylinder is equal to the lateral area plus the area of the two bases. So that's equal to, well, the lateral area was circumference, so 2 pi r. This supposed to be height. Wait, lateral, okay, so 2 pi r times h, that's the lateral area, plus 2 times pi r squared. So the lateral area is the circumference times the height, and the bases are pi r squared times 2. That will give us the total area. And that's all equal to 24 pi. All right, see if you can figure out what to do there. Add your r, put your r in for r. See if you can simplify that up. See what happens. And you can always ask me in class. Okay, number 14. The volume of a cylinder is 200 pi. Find the height if r equals 3. Okay, so the volume of the cylinder is 200 pi. So volume equals pi r squared times h. So 200 pi is our volume, that's what we put in for that, equals pi, our radius is 3, and then we put h. Now we need to solve for h. Okay, so this is 200 pi equals 9 pi times h. I can divide both sides by pi and that gets rid of that. So I just end up with 200 equals 9 times h. And to solve for h, you just divide both sides by 9. And you get h equals 20 over 9. See? Fraction answer. Now let's find the radius if the height is equal to 2. Well, so we'll use the same formula for the volume of a cylinder, since that's what we're given. Now we'll plug in the volume is 200 pi, and that equals pi and then we have r squared. We don't know what r is, and the height is 2. So now we're going to solve this equation right here for r. We want to find the radius. Okay, pi is on both sides, so we can divide those out, and we get 200 equals 2r squared. Right, 2 times r squared. We want the r squared by itself, so divide by 2. And we get 100 equals r squared. And to get r by itself, take the square root, and we get r equals 10. Okay, that's it. A lot of practice. I hope you're doing it and really learning from it. You guys rock. You can do this. Bye.